It's right here. Making sure you know. I'm passing. That's fine. The history on the college side.
Okay, always pay attention to what it's asking for. If a problem says give the exact value, that means you're gonna have your answers in log form, natural log form, radical form, exponential form, whatever. If it says round, then you obviously round. So an exact answer is an exact answer. Now I'm gonna type in the calculator and just see what it says. What we have here is e to the 2x minus 4e to the x plus 3 is equal to 0. It might not look like it, but this is a quadratic. If you remember last semester, we looked at problems that might have looked something along the lines of x to the 4th minus x squared minus 6 equals 0. And to factor that, we could turn it into a quadratic. The relationship that we're looking for is your first exponent, your degree. If your degree is twice the middle term, then we can write it in exponential form. Okay? Is 2x twice x? Yes. So because this is true, we're actually going to rewrite this as a quadratic. Do you remember using u's? Okay. So
a union thing?
not that, no. So here, this is e to the x. I'm going to let u equal e to the x. Well, because I make that assignment, I'm going to let u squared equal, well, that would be e to the x squared. And e to the x squared is simply e to the 2x. And by making the substitution, it's going to definitely look like a quadratic. So e to the 2x, that's the same thing as u squared. Minus 4, e to the x, but e to the x is u, plus 3 equals 0. And that is a very basic quadratic that we can factor. I need two numbers that multiply to get 3, but combine to get negative 4.
1 and 3, or 1.
Yeah, 1 and
1 and 4.
3. Negative.
Negative
3,
3,
negative
negative
1.
Negative 3 and negative 1. So
Why did
u
you-
minus 3,
On the
u minus 1 equals 0. And now I have two factors multiplied together that get 0. Well, the only way to factor things together and get 0 is if one or both of them are 0. So u minus 3 equals 0, or u minus 1 equals 0.
So 3
U equals 3,
U equals 3,
or U equals 1.
u equals 1. But we don't have any u's in our problem. So we have to go back up. I didn't say that because that's what I was doing on the page here. U was e to the x. So this isn't really u equals 3. It really means e to the x equals 3, or e to the x equals 1. And now we need to solve those.
natural log.
Why?
Because it makes the E a 1.
Yes.
Oh my
So-
God, this is smart.
My exponent is a variable, therefore this is exponential. To undo exponential, you use logs. Because we're base e, we're going to take the natural log of both sides. So taking the natural log of both sides, we get natural log of e to the x equals 3. X comes out front, natural log of e is just 1, so I forgot a natural log. Y'all let me do it. If you take the natural log of one side, gotta take the natural log of the other side. So x equals natural log of 3. And that's going to be the exact answer, because natural log of 3 is going to be some kind of a decimal.
1.0986.
Natural log of e to the x equals natural log of 1. X comes out front. Natural log of e is 1, so I get x equals, and the natural log of 1 is a specific number. Natural log of 1 is 0. At this point, you should always, and as you're doing your homework, do this. I'm not going to do it in the class time because it takes a lot of time. You need to check your answers. Okay? These answers do work, both of them plug in, they both check. So we could write our solution set as a set of numbers containing 0 and natural log of 3. Any questions or comments, or yes?
I'm confused how you got to like x equals. Like, how did you get rid of the natural log and the e?
There's a property that says the log, that's nice, that's a large, log base A of A. That's the wrong property.
You got it. I believe in you. Power through it.
Log base A of A is 1. Yeah, that's right, Mike. Yeah, so log base A of A is 1. It's just a property. So log base 10 of 10 is 1. 10 to the first power is 10. A to the first power is A. Okay? Natural log is the same thing as writing log base E. But instead of writing log base E, we write it as LM. So log base E of E is still 1 because E to the first power is E. So that's just a property. There's another property that says you can take that exponent and bring it out to the front. So this is really x natural log of E. Well, the natural log of E is 1, so I have x times 1, which is x. Okay. Other questions? Okay. To solve an exponential, you take the log. To solve a log, you make it exponential because they're inverses. Okay? We're going to solve 7 natural log of x is equal to 28. The first thing we must do is have the log by itself. The log currently is not by itself because there's 7 with it. How do I make that 7 go away?
Minus.
No.
Divide.
Can you put the 7?
This is multiplied together. Divide both sides by 7. I get natural log of x equals 4.
4.
But I'm solving. I want to know what is x.
So would you subtract
What?
the natural?
There's nothing added.
Oh, yeah.
Okay.
Divide.
There was another property that we looked at that said, okay, if I've got some base raised to the m power, and that same base is raised to the n power, if a to the m is equal to a to the n, what must be true about m and n? M has to equal n. Okay? We're going to use that property going the other direction. What I have here is natural log of x and 4. I'm going to make these exponents by choosing some base to put down here. And the base I'm going to choose is whatever base that is. So what base is natural log? E. So because natural log is base E, I'm going to put, I'm still in red, I think. I'll put an E right here and an E right here. So what I did was I made natural log of x and I made 4 both exponents. Why did I do that? Ugly math, but this is how it works. That cancels.
How's that ugly? That's easy.
Okay? So I get x is equal to e to the 4th power.
Oh wait, hold on. Let me write this down.
And that's it?
Yep. So, and of course, we want to go back and check it and plug it in. If you plug that in, the 7's already here. Natural log of e to the 4th. The 4 comes out front. So now I have 7 times 4. Natural log of e. Well, natural log of e is 1. And 7 times 4 is, so it checks. So the solution set would be e to the fourth. Give B a shot. At least get it started.
Nope. I'm just waiting.
Oh shoot, you scared me. I don't know how to do it. Can I close?
Do you divide or do you continue? I don't know.
Yeah.
I'm just stuck.
You're stuck.
Do you divide or just?
Most
No,
of you are
it's
just
not
copying.
first.
Most of you are like copying each other
Would you?
or making up your own.
I added.
Hey, leave me alone.
I did plus 19.
I didn't know what to do.
Distributed. That's not how this works. That's not how any of this works.
Sir, what do you want us to
You
do?
can't distribute, guys.
Okay, okay, let me
Divide? What?
I tried that just now. So,
Yeah, this,
Just flat out
our world,
guess.
we can make up whatever we want.
Interesting.
yeah, honestly, technically, all math is made up.
Actually, they don't actually.
Can't just make this disappear. Okay, you're
I
taking
didn't
the
divide
whole
my
thing.
percent.
These two things aren't being multiplied together.
Oh.
But I'm doing the word program.
I should try.
What? Can't stop that.
Can't do that.
She can make them.
Yeah, no, I'm giving up.
Now let's set up. Okay. What's the base?
2.
How do you undo logarithms? You make them exponents. Okay?
We have to
Oh.
start off with the exponent thing.
Really?
This is gone.
Wow.
I now have x cubed minus 19 equals, what's 2 to the third power?
That's
Nice.
Second, third. 8.
what?
I hope it's not 9. It's an even number.
Okay? I want x by itself. What should I do?
Add the 19.
Sounds great. X cubed is 27. I want x by itself. What should I do?
Square
Divide.
x 3. Oh wait, divide. Wait.
Cube root. Cube
Thank
root.
you.
Wow.
The people who watch your things probably think that we're just.
So x equals the cube root of 27 is?
3.
That was a lot easier than I thought. I didn't
Yeah.
know whether to divide the entire thing or like what, distribute it.
Another thing you could have done, I mean, I show it with exponents. Remember base to the power equals a thing? 2 to the third equals that? Well, that's what I got.
I hate this. I'm going home.
Take me with you.
Is the final gonna be hard? Is the final gonna be hard?
Why? Nothing we've done here has been hard. Why make the final hard?
Are you
Do we
kidding
have a
me?
final?
Have you seen? Have you seen us struggling? It took me like a whole class period to do one problem, and you because I was
Awesome.
doing that.
I
Hey, wait, do we have a final?
Yes. You have 2 tests left.
No, not that final.
Like, no, but like final.
Your final for you, final exams.
Yeah, like if I can't exempt you,
You have to be at school that day.
yes, and
Will you still
is
make us take
that
the test?
day-
Yeah, are you giving an exam?
Really? Oh,
You are giving an exam, okay.
Wait, what are we doing?
party.
Moving on.
We're gonna walk
Remember
around
that?
over the
Remember that pizza party he said?
Oh
Yeah,
yeah,
what?
Yeah, but we didn't win.
But he still said it because we still.
because we donated so much money.
Oh yeah, that never happened.
Now what?
Oh wait, let me hold up.
You're racist.
Can you multiply?
Oh, it's
I said
10,
racist.
it's 10, right?
Huh?
To the power of 10. Oh wait, but they go,
Okay, so here's the problem.
I don't know.
If there's only one logarithm, all you have to do is get that logarithm by itself and then make both sides an exponent. If there's only 2 logarithms and nothing else, you can put one logarithm on one side and one logarithm on the other side and hope they're the same base and make them exponents.
Is it the same days?
If you have 3 logarithms, you've got a potential problem.
It's not solvable.
But they all have the
But-
base of 10, right?
Yeah, they're all base 10.
Let's cancel them
Can you
all.
write that
Why?
as a
would-
single logarithm?
Fraction.
Yes.
Yes.
Yes, there's a fraction involved.
You didn't have to plan that.
Okay? So if you have a difference of logs is equal to the log of the quotient. Okay? This is a difference of logs with the same base. So because we have the difference of 2 logs with the same base, I can write it as a single log with the positive logarithm being on top, so x plus 6, and the negative logarithm goes on bottom, x plus 2.
Now we put it.
How can the log of that mess equal the log of x? Think about it.
X, no X.
How can that be true?
Excellent. We really know.
Oh, wait.
Okay, let's look at this again.
So,
How can that be true?
they all have a base of 10.
If they're all set to E.
And,
I-
If m and n are equal.
yes.
How can that be true?
If A and B are equal.
Isn't that what we have? Right? If the log of this mess is equal to the log of x, doesn't that mean that that part equals x?
That's the answer.
Now we're getting x by itself.
Oh,
There's a bunch of X's.
Dang it.
I don't know if I'm good with that.
Now
Wait,
what?
do those 2 X's cancel?
Can't because you're adding or subtracting. You can only cancel when you have products divided by products.
So what do we do with them?
Factors over factors cancel. So what do we do?
Multiply by 2.
Why?
Ooh, we could,
Go to the bottom.
factor. I don't know.
Multiply by x plus 2
Why?
both sides. Because it cancels out on the bottom of the left.
And what else is that doing?
Making an equation easy to solve.
Because what's gone? Because you don't have what anymore?
Fraction.
You don't have fractions anymore, yeah. I mean, how do you get rid of fractions? You multiply everything by the common denominator. In this case, I only have one fraction. I only have one denominator. if I multiply both sides by x plus 2, the left side cancels. I now have x plus 6 equals, and that needs to be distributed.
Plus 2x.
But the beauty of that is there's no fractions. What do I have now?
Subtract 6.
Why?
Because.
So
'Cause you
could
wanna
we-
get
so
it
you
to
just
the
want
other
the X
side.
to be alone, right? So the X to be alone
Oh,
on one side.
Wait, you would subtract 6.
That's what she said,
Oh, I thought she said x.
Ryan.
I thought she
They
said
rhyme.
X.
I guess.
6x.
No, can't do that.
I was saying take the square root.
Can't do that. What are you thinking?
Subtract the x.
Why?
You get x squared plus x. I don't know.
Oh, you could factor
It's on
it.
the
You
x
could-
side.
No, you can't factor that or anything.
What does this look like? What's kind of appearing up here?
A quadratic.
Quadratic.
Perfect. How do you solve quadratics? You set them equal to
0.
0. So you're both right. Yeah, subtract x and subtract 6, right? Because then we're gonna have 0, then we're gonna have a quadratic. So so we have x squared. Subtracting x from both sides, 2x minus x is plus x. And subtracting 6 from both sides is minus 6. And I flipped it around, put it equal to 0.
Hold up, where'd 2x go? Oh, never mind, I see it.
Okay. So factor that. I need two numbers that multiply to negative 6 but combine to 1.
2 and 3. -2
That's
and -3.
fine.
Wait, no. Negative. Wait.
Negative 2 and 3.
Oh yeah.
So x plus 3, x minus 2 equals 0. So x equals negative 3 or x equals 2, right? Okay. One of these doesn't work. So all along, we should be checking our answers. I've been skipping it. We are going to go ahead and check this one. So let's check x equals negative 3. If I plug negative 3 into the original problem, I have log of negative 3 plus 6 minus log of negative 3 plus 2 equals log negative 3. Sorry, I ran out of room. Negative 3 plus 6. I have log of 3 minus log of what?
Log of x plus 2.
Negative 3 plus 2.
No, yeah.
Negative 1. That's a problem. Why is that a problem?
Wait, because those in there,
Because it can't be a negative number. Whoa, he got
That
it.
was so good.
If you play baseball.
Why is that a problem?
As it doesn't match.
Because it's a
because
negative.
it doesn't match.
What's the calculator show?
I mean, that's
log
just
is
what I
negative
saw.
and, negative.
What's a log of negative 1?
0.
Oh, 0.
It says
Oh,
error.
error.
Okay. Guys, you can't take the log of a negative number.
Oh.
So all of our math was spot on, but this time we actually got an answer that did not work. So we throw that one out. This is what's gonna happen. If you get an answer that doesn't work, you throw it away. It's extraneous, it's extra, okay? If we check the negative 2, I'm sorry, check the positive 2. We have log of 2 plus 6 minus log of 2 plus 2
You're gonna run out of room.
equals, got plenty of room, log of 2. This is log of 8
Log of 8.
minus
Log of 4.
log of 4
Equals log of
log
2.
of 2.
This,
What you're-
this would be log of
Log of 4.
8 divided by 4,
Log of 2.
and 8 divided by 4 is 2.
2.
Log of 2 equals log of 2.
Yes.
It checks. This one's kind of screwy if you're because if you went like that, you'd say, oh, well, okay, log of 3 minus log of -1, that would be log of 3 divided by -1, which is -3. So log of -3 equals log of -3. Looks like it works to me, except you can't take the log of a negative number. Not right now. Somebody's gone. So what's the answer? That one worked?
2.
Okay. And we throw the other one away.
It has been cancelled.
Okay.
So confused.
This is easy stuff.
Oh, I can't
Yeah,
wait for hard stuff.
We don't do that in this class.
Really? Yeah.
So then technically this is the hard stuff, it's just
Hard for our class.
Hard for my brain.
hard to understand. Easy concept, hard to.
Get it going.
No, what?
I think you forgot to mention the part where you're going to teach us.
Go.
Dang.
Alright. Any help?
No, I'm not calling him out. I'm saying he's teaching us. I don't know how to do this.
It's a lot like the one we just did, but different.
There's brackets.
I don't care. You're taking the log of something. Log base 2 of something is 3. It's not a big deal. I don't care. I don't care how big it is and how ugly it is. Do it in pieces that you know. The log base 2 of something is equal to 3. What's the base?
10.
2.
2. What's the power?
3.
3 equals what?
2.
The thing.
The thing.
What thing?
That thing.
I'm confused.
Where?
This
do you
does
see-
not process in my brain.
Wait, so,
Listen,
oh,
this is log base 2 of that thing is equal to 3.
Wait, I think I know how to do one.
What's the base?
2.
oh,
2.
this is 8.
What's the power?
3.
So 8.
Equals what?
The thing.
The thing, which is that ugly mess right there. Go with it.
Even over that.
I know, then write it down.
See.
No,
I don't.
not that part.
Yes.
Wait, so what, the base? Oh,
Okay, let me write this down again.
Well, we get that part.
Okay,
Log base thing equals
I'm
power.
going to convert this. This is logarithm. I'm going to convert it to exponential.
Put 7 times 4, 28.
So we just transfer it to that.
okay, thank you.
Wait, did I do it right? I think
Okay.
I did a little something completely wrong. A little something.
Don't dodge again. It's his fault. He dodged it.
I dodged.
Could you do that?
Yeah, that's what I said.
Oh!
Now clean that up.
Oh.
Foil, set it equal to 0. Factor
I always
it.
forget the
Go.
oi.
Factor.
Okay, so you might want
Factor
to
it.
check
Hey,
this
what
because
is- I
this
don't
is
think
what
I'm
I
doing it
understood.
right.
In fact, I just.
Yeah, I've been distributing, and now so far I've got -20.
Yeah, me too.
Cough one more time, I dare you. I'm just.
I'm stuck right
Hmm?
Where are you supposed to distribute?
You're going to have to double distribute. You're actually
I
going to
think
end up
I'm making
foiling
up
it.
my own math.
-12.
Okay, keep going.
Okay, so you know what I'm gonna do?
Keep going. That's exactly what I told you to do.
I'm gonna do.
Well-
You got this. That's what this is.
Uh-huh.
Log, base, thing, power.
Wait, wait,
Base, power, thing.
What happened to log?
That's the whole idea. It's gone. That was the point.
Wait, I think I did it wrong. Was that just what I was supposed to do?
wait, I need help factoring.
Okay, factor it.
I forgot how to.
Factor it. Good.
I forgot how to. That's the thing.
Sure. Get busy.
Okay.
What are you doing?
I don't know, I thought I had to.
2.
2 times 10 is 20.
8 times C.
I know, but I can't remember.
What are you
Dang.
Wait, do we distribute right here?
She quit missing school.
Do we distribute right here?
He's got a point.
You can't.
Wait, 8 times
Before.
C.
Yes.
Okay.
What do you mean 8 times C?
It's the first.
I mean 8 times
The
C.
first coefficient.
You
times
missed.
You were
last-
so close.
You thought I was trying to get it in. I tried to get the trash can.
Oh,
That's 3 times
It's all about
Winner.
perspective.
times C.
he won. You get $1. It's imaginary. I don't have any more.
Why didn't you just say a high five?
Oh, because money's more cool.
Negative.
Oh shoot, I'm stupid.
Wait, so 8 times
16.
C is.
Negative 60? Where?
How'd you get
I
that?
don't know.
I got
You said
60.
You said 8 times C.
Yeah, I just got
It's 3
regular
times
C.
negative 20.
No, it's positive 20.
You made me feel like I did everything completely wrong.
It's positive 20.
Okay, I really don't.
I did not.
No, I
Because
did the
it's
trash can.
negative
That's what I was
on
aiming
this
for.
side, but then when you equal it out to 0, you're adding 20 to both sides.
Okay, yes, yeah. We got it.
Wait, and then we have to equal
I
it
don't know how to
negative.
find that part of the thing.
First one's first.
How do you do that factoring thing in the calculator?
Yeah. It's like x divided by c.
Outside times outside.
Outside times
12x.
outside. Yeah, 12x.
Negative 12x.
Negative 7x.
Inside times inside.
Inside times inside.
Combine those.
Negative 19.
Oh,
Last time
Plus
class.
28.
That's plus negative. Oh, yeah, plus.
Make it equal to 0.
So I did do it right.
we're just gonna wait until you're done.
0.
8 times C.
60.
I need two numbers multiplied to get 60. So combined to get negative 19. And-
12.
Hey, that was my first guess.
Negative 15 and negative 4. They both have to be negative. So negative 15 and negative 4. Negative 15 times negative 4 is positive 60. Negative 15 plus negative 4 is negative 19. I'm going to break this guy up. So I have 3x squared, and I don't care which one you do first. Factor by grouping. What does my first group have in common?
3.
3x.
What's left?
X
Minus
squared. Wait, no.
It'd be,
Minus 5.
Okay. What does my second pair have in common?
4.
4, but because the first term is negative, it's going to be a
Negative.
negative 4.
Yeah.
If I factor a negative 4 out, negative 4 times what is negative 4x?
X.
And negative 4 times what is 20?
Negative 5.
I now have two terms. What do those two terms have in common?
I was gonna say.
X squared 5.
X minus 5. If I take away an x minus 5, what's left?
3x minus 4.
How can this be true?
If they're the same.
X equals 5 or
I don't.
x equals, add 4 to both sides, divide by 3.
4 thirds.
4 over 3.
Huh? So is that the answer?
Then we check them. Plug them in.
The very first equation.
I didn't do it. Never mind. Don't even answer.
So checking the 5, we have 15 minus 7 is 8. 1. 8 times 1 is 8. 2 to the third power is 8. That one checks. Plug in 4 thirds. 4 thirds times 3 is 4.
Yeah.
4 minus 7. Negative 3. 4 thirds time minus 4.
Negative 8 thirds.
Negative 8 thirds. Negative 8 thirds times negative 3.
8.
Positive 8. 2 to the third power is 8. They both check.
So the solution, whatever it is.
What? I don't know what you just did.
We just plugged these two numbers in.
I know, but the way you said it was, I don't follow.
I just said it the way the math says.
Why does math have a language?
Yeah, I was gonna say math
Why
is a
don't
foreign
they
language.
teach that as a language?
Yeah, this
Is
is
it-
our
is it-
foreign language.
There's a certain math that is a different language, is it not?
That's this,
That's called mini math.
Exactly.
reading the alphabet or whatever.
Come on with that Greek.
It's kind of singular.
Question?
What's that one thing that's like?
We will
delta or
continue
something?
Tomorrow.
I don't remember.
Oh, yay, another good thread.
Looks like the next test is gonna be next week, be Tuesday, Wednesday, and Thursday.
Are we testing all day, or is it?
That's why it's 3 days. So you only get 2 days to do it. But I have freshmen that are testing on Tuesday and juniors are testing on Thursday. So because of that,
So it evens out.
yeah, you'll be testing 2 days. So if you're here all 3 days, you need to make sure you have something to do on that Thursday.
Wait, are we doing something tomorrow, bro?
What do you mean?
Like, are we just finishing here at 5?
Yeah.
Will we finish 4-5 tomorrow?
Hopefully.
I'm not gonna be here tomorrow.